नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार दुर्शेट्टी, फैकल्टी ऑफ इंस्ट्रूमेंटेशन। मैं आप सब लोग को यहां स्वागत कर रहा हूं हमारा महा अभ्यास सीरीज पर। इंस्ट्रूमेंटेशन की जो कोर सब्जेक्ट्स है वो कोर सब्जेक्ट्स का लेक्चर चल रहा है। सेंसर्स एंड इंडस्ट्रियल इंस्ट्रूमेंटेशन में ऑलरेडी लास्ट क्लास में थोड़ा डिफरेंट वेराइटीज ऑफ क्वेश्चन देख लिया है। आज हम और कुछ क्वेश्चन देख लेंगे। सो जितने लोग लाइव में हैं मुझे एक बार ऑडियो वीडियो कंफर्मेशन कर दीजिए, ऑडियो वीडियो सब कुछ क्लियर या नहीं, एंड आपका बैकग्राउंड भी बता दीजिए, आप कहाँ से हो। आप जो इंस्ट्रूमेंटेशन बैकग्राउंड से है तो थर्ड ईयर और फोर्थ ईयर और गेट एस्पिरेंट, गेट ऑलरेडी रिटन, गेट गुड रैंक, ओके, रैंक इंप्रूवमेंट, जो भी है आप बैकग्राउंड, प्लीज टेक्स्ट मी एंड if for your information, kind information, so just I would like to add my telegram line. So on the telegram you can be in touch with me, so my students will be answering the questions. There are many students who are practicing gate questions there. So this is my telegram id, so you can scan it and you can immediately join in the telegram group at the rate Sathish Kumar sir PW. Okay, so this is our telegram group and coming to the topics today, Maha Abhyas, Sensors and Instrumentation, महा अभ्यास करेंगे। जो हमारा क्वेश्चंस है, गेट क्वेश्चंस है, गेट मॉडल क्वेश्चंस है, एंड जो प्रैक्टिस क्वेश्चंस है उसका अनुसार हम डिस्कस करते जाएंगे। सो जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए बेटा, ऑडियो वीडियो सब कुछ क्लियर या नहीं। जल्दी से जल्दी ज्वाइन करो बेटा, जितने लोग लाइव में हैं मुझे एक बार कंफर्मेशन कर दीजिए, ऑडियो वीडियो सब कुछ क्लियर या नहीं। चलो अब स्टार्ट करेंगे क्वेश्चंस महाअभ्यास का। या प्लीज ट्राई टू आंसर दिस क्वेश्चन। फर्स्ट लेट अस स्टार्ट फ्रॉम दिस क्वेश्चन। गेट 2025 का क्वेश्चन है ये। So if you see this question is from GATE 2025. So I'm giving some polling also. So in the polling, what is given, you please make a note of this. Attend the poll. Yes, yes. Yes, संजय के ऐसा सवाल एवरी ईयर आता है, एक इजी क्वेश्चन आ रहा है एवरी ईयर. So if you see now, rotary variable differential transformer, so that is LVDT is for linear displacement, rotary will go for angular displacement. Next, thermocouple will go for temperature measurement, ionization is go for vacuum measurement. Okay, strain gauge is equal to force measurement. So if you see now, the P goes to 3, next Q goes to 4, next R goes to 1, S goes to 2. So P goes to 3, Q goes to 4, R goes to 1, S goes to so option D is the right answer. So the right answer is option D. So आपको poll आ रहा है? Please, are you participating in the poll? Okay. Poll नहीं आ रहा है आपको? Please select the poll. Poll use करने की कोशिश करो भाई. Yeah. Attempt with a poll. Okay. Yes. So let us go for another question. Try to answer this question. गेट 2025 का सवाल है. The resistance of a thermistor. Question is on thermistor topic. The resistance of a thermistor is measured to be 2.25 kilo ohms at 30 degrees Celsius and 1.17 kilo ohm. Its material constant beta is dash. So at 30 degrees Celsius means you have to add 273 Kelvin. So it will become as how much? 303. So 30 plus 273 it will become as 303. Calculator use करो बेटा, जरूर कैल से यूज करना पड़ता है. Please use a calculator. Okay. So it is going to be 303 Kelvin. So 30 degrees Celsius means that corresponds to how much? 303 Kelvin. At 303 Kelvin, the resistance was 2.25 kilo ohms. Next, 1.17 kilo ohm at 60 degrees Celsius. 60 degrees Celsius. So 60 plus 273, that is 333 Kelvin. At 333 Kelvin, the resistance was 1.17 kilo ohms. Then its material constant beta is equal to dash. So we'll write this as R0, this as RT, this as T0, this as T. Okay, so now if I use that expression, actually this is the expression RT is equal to R0 into exponential beta 1 by T minus 1 by T0. Okay, उसको सिंप्लीफाई करने के लिए मैंने RT by R0 is equal to exponential beta 1 by T minus 1 by T0. So if you take the natural logarithm, ln RT by R0 is equal to beta into 1 by T minus 1 by T naught. Okay. So now if I am going for this ln, RT means this. Sorry, sir, this is T, not T. This is T naught. This is T naught. This is R naught. This is the T and this is the RT. So ln RT, that is 1.17 divided by 2.25 is equal to beta, we don't know, 1 by T, that is 333 minus, that is 1 by T naught, that is 303. Okay, 60 plus 273, 333, 30 plus 273, 303. So we can write 1 divided by 333 minus 1 divided by 303. So we're getting here minus 2.973 into 10 power minus 4, and this is 1.17 divided by 2.25. Minus 0.6539. So this gets cancelled. So beta is equal to 0.6539 divided by 2.973 into 10 power minus 4. 0.6539 divided by 2.973. 0.6539 divided by 2.973 into, so 2119 आ रहा है ना, 2199.461 per Kelvin आ रहा है, Kelvin. So this is the beta. Is my answer is right? Anybody can check it? या संजय भाई इसका आंसर बताओ ना, इजी है तो बताओ यार, कमेंट क्यों डाल रहे, आंसर बताओ. इजी है लेकिन आप आंसर नहीं बोल रहे ना. चल, प्लीज मेक इट आंसर. चलो, now let us go for one more question of GATE 2025. Try to answer this question. GATE 2025 का सवाल है ये. Try to take your own time and try to answer this question. The primary coil of a LVDT, linear variable differential transformer, is given here. Do this. So if you see the question, the primary coil of a linear variable differential transformer is supplied with AC voltage as shown in the figure. The secondary coils are connected in series opposition and the output is measured as a true RMS voltmeter. The displacement x of the core is indicated in mm on a linear scale. At the m position x is equal to 0, the voltmeter reads 0 volts. So if you see the table of displacement and the voltage, so this V naught, the displacement x of the core indicated in mm on linear scale, at the position of x is equal to 0, the voltmeter reads 0 volts. If the voltmeter reads 0.2 volts, so 0.2 volts for a displacement of how much? 2 mm plus 2 mm. Then for a displacement of minus 3 mm is asking, so we can calculate the sensitivity. Sensitivity is equal to change in output by change in displacement. So that means 0.2 minus 0 volts divided by 2 mm minus this. So what happens now? 0.1 volt per mm aayega. So this is 0.1 volt per mm. 0.1 volt per mm. So now he is asking for a displacement of minus 3. So if you want to get the output, so the output is equal to sensitivity into input. Output is equal to sensitivity into input. So this sensitivity is given as 0.1 volt per mm into input displacement is mentioned clearly as minus 3 mm. So minus 3 mm. So now the mm gets cancelled and the answer is going to come as minus 0.3 volts. Okay, so the right answer, the voltmeter reading is what? Minus 0.3 volts. Any doubts? Thank you, sir. Thank you very much. Thank you very much. So D is equal to how much here? 140 into 10 power minus 12 coulombs per Newton divided by epsilon value is mentioned here. What is epsilon value? 12 into 10 power minus 9 farad per meter. थैंक यू सर। अगर हमारा सुजल पटेल सर भी है हमारा सेशन में। सो बच्चों, आप सिग्नल्स एंड सिस्टम्स का महारथी है हमारा सुजल कुमार सर। आप उसके पास इतना सारा क्वेश्चंस है, ऑलमोस्ट थाउजेंड्स ऑफ क्वेश्चंस ही सॉल्व्ड इन द लाइव क्लासेस यूट्यूब सेशंस। सो जितने लोग अगर आपने रिवीजन कर ले महा अभ्यास पर सार का पूरा नोट्स, पूरा पीडीएफ, पूरा लाइव क्लासेस, पूरा क्वेश्चन प्रैक्टिस कर लो, जरूर आपको सिग्नल्स में 8 मार्क्स का सवाल आने वाला है। 8 मार्क्स जरूर हमारा नोट से ही आएगा, सुजल सर नोट से। ओके, एप्सिलॉन कितना है? एप्सिलॉन इज इक्वल टू 12 इंटू 10 पावर माइनस 9 फैरड पर मीटर। सो इसका सिंप्लीफाई करो, कितना आएगा कैलकुलेट करो। सो कैल से यूज करके बताओ कितना आएगा। ओके, सो 140 डिवाइड बाई 12, सो दैट इज कमिंग एज 11.66 इंटू 10 पावर माइनस g is equal to d by epsilon, am I right? d is given 140 picocoulombs per Newton, epsilon is given 12, it's everything perfect. वन 40 by 12 into 10 power minus 12 plus 3 minus 3 होगा. So this is coming as very less is coming na 0.0116 volt meter per Newton. Is it right? Anybody can cover the mistakes? Okay, E naught मुझे चाहिए E naught. E naught is equal to, I can take it as G into P into T. So G कितना आ रहा है? 0.0116. Pressure is equal to force per area, that is 8 divided by area. Area is 36 into 10 power minus 6. And the thickness is mentioned as 1.5 mm. So 1.5 into 10 power minus 3 होगा. So उसका आंसर कितना आएगा एक बार कैलकुलेट करो. Into 8 into 1.5. So divided by 36 into 10 power 3. So that is coming as 3.88 volts. So मुझे आ रहा है E naught का वैल्यू इतना आ रहा है. Any other answers? Any other answers बेटा? 3.88 volts से बिना any other answers? Can you tell me? चलो E naught आ गया. नेक्स्ट कैपेसिटेंस कैलकुलेट करो. कैपेसिटेंस का वैल्यू कितना आएगा? So if you see the capacitance value, what is the capacitance value? Can anybody tell me? Capacitance का कितना आएगा? कैपेसिटेंस कैलकुलेट करो. कैपेसिटेंस के लिए एप्सिलॉन ए बाय थिकनेस यूज कर सकते हैं ना आपने फार्मूला को. ओके, कैपेसिटेंस के लिए आपने सो कैपेसिटेंस Cp इज इक्वल टू एप्सिलॉन इंटू ए बाय टी. ओके, सो व्हाट इज द एप्सिलॉन? Epsilon is given here as how much? 12 into 10 power minus 9. So this is 12 into 10 power minus 9, and the overlapping area is given as 36 into 10 power minus 6. So this is 36 into 10 power minus 6 whole divided by thickness. थिकनेस कितना दिया है क्वेश्चन में? 1.5 mm थिकनेस दिया था ना. सो आपने उसको 1.5 इंटू 10 पावर माइनस 3 यूज कर सकते हैं. ओके, सो अभी कैपेसिटेंस कितना होगा? सो चेक करो. 12 इंटू 36 बाई 1.5 कितना आ रहा है एक बार चेक करके बताओ. सो 12 इंटू 36 divided by 1.5. So 288, 10 power minus 9 minus 15. So 288 picofarads are. That's it. Chalo, let us go for the next. Next one is the strain is asking. After the capacitance, what is asking? Is asking the strain. So strain के लिए हम क्या use कर सकते हैं? So stress is equal to Young's modulus into strain का formula use कर सकते हैं. अगला use कर सकते हैं. Stress is equal to Young's modulus into strain. So from this Young's modulus is equal to stress by strain लगाओ. Stress by strain लगाओ. So what is the stress? So stress is equal to force per unit area. So this is force per unit area into strain. So क्वेश्चन पूछ रहा है स्ट्रेन पूछ रहे हैं ना. So strain के लिए हम क्या फॉर्मूला लिख सकते हैं? So strain is equal to 1 by Young's modulus into stress कर सकते हैं. So that is 1 by, what is the Young's modulus? Young's modulus is, this is 11.5 10 power 6. 11.5 to 10 power 6. And stress का फॉर्मूला क्या है? स्ट्रेस का फॉर्मूला force per area, that is 36 into 10 power minus 6 divided by, sorry, force is equal to how much? Force is equal to 8 newtons. So here 8 newtons per area is equal to 36 into 10 power minus 6. Okay, please make a note of these points. आंसर कितना आ रहा है देखो, 11.5 10 power 6, there 6 gets cancelled. Okay, 10 power 6 gets cancelled. So कितना आ रहा है? 8 divided by 11.5 0.610 divided by 36. So 0.01932 आ रहा है. 0.01932. So that is a delta T by T, which is what we call a strain. Okay बेटा, done. चलो sorry, the flickering happened camera में. Yeah, can you answer this particular question? Yeah. Oh, no signal आ रहा है. Yeah, please answer this question. 4 strain gauges in a Wheatstone bridge configuration are connected to an instrumentation amplifier as shown in the figure. From the choices given below, the preferred value for the common mode rejection ratio is asking. Common ratio of the amplifier in decibels would be dash. So this is a combination of both analog and sensors. चलो आंसर बताओ यार. 4 strain gauges. So 4 strain gauges means it is a what bridge? It is a full bridge. So if you see, this is the full bridge. So it is a full bridge. So generally for a full bridge, we have an expression. So for a full bridge, we have an expression. What is the expression for full bridge? So we are having several types of bridges: quarter bridge, half bridge, full bridge. Yes or not? So full bridge के लिए expression क्या होगा? क्वार्टर ब्रिज के लिए VS/4 del R by R होगा, हाफ ब्रिज के लिए VS/2 del R by R होगा, फुल ब्रिज के लिए VS into del R by R होगा. सो आपको पता है ना ये एक्सप्रेशंस, सो आप यूज कर सकते हैं. V क्वार्टर ब्रिज इज इक्वल टू VS/4 into del R by R. नेक्स्ट हाफ ब्रिज के लिए क्या होगा? दैट इज VS/2 into del R by R. नेक्स्ट फुल ब्रिज के लिए क्या होगा? दैट इज VS into del R by R होगा. So in the question, what is given is a full bridge. Why? Because, sorry, there is a question. So this question, so whatever is given is a full bridge. So why? Because R plus delta opposite, R minus delta, the product is not equal. So VS into del R by R. So I can find out the gain. Instrumentation amplifier is having gain. So this is a V naught. So this is a V bridge. So what will be the V naught? V naught is equal to gain into V bridge. So that gain we don't know. So this is VS into del R by R. I can take it out. Okay. So he's asking what? In the question, what is asking? Common mode rejection ratio is asking. So actually speaking, there is no information of this del R and all are those things. Okay, the information of this, nothing is there here. So what we can take, common mode ratio is equal to always preferred value of CMRR. CMRR का common mode rejection value क्या होना है? So CMRR is equal to common mode rejection ratio, that should be equal to AD by AC. Okay, so AD by AC means what is AD? AD is a differential gain, so that is V naught by V bridge. So that is V naught by V1 minus V2. Okay, so that is coming around what? That is VS into del R by R is coming, but the information of that is not mentioned here. Okay, and the common mode gain is equal to what? Common mode gain can be the VC, so that I can take it as V1 plus V2 by 2. So in a CMRR, common mode rejection ratio must be very, very high. So for that, differential gain must be high, common mode gain must be low. So in the given options, if you see, whichever is see, there is no information clarity नहीं है, कुछ डाटा नहीं है, R का information नहीं है, supply voltage है, gauge factor का information भी हमारे पास नहीं है. So but we can choose the highest value. So 100 is the highest value. So CMRR should be very, very high. That is the only hint. Actually ये question अनलॉक का question है, लेकिन अनलॉक का question में आपने strain gauge को हटा करके आपने करवा दिया. Okay, चलो let us go for the next question. Yeah, see this question also, very easy questions. Sometimes very easy questions are asked in the gate. Thermocouples measures the temperature based upon what? So when two different materials like this is a material A and this is a material B. When two different materials join together, then two junctions are formed. So this is a junction 1, this is a junction 2. Two junctions are formed. So we are mentioning the T1 here, T2 here. So T1 greater than T2, then this becomes as hot junction and this becomes as cold junction. then the flow of electrons will take place like this. So this flow of electrons is proportional to T1 minus T2. So that will be generating hot junction minus cold junction. If you remove the proportionality, you are going to get S into TH minus TC. So this is what we call as Seebeck effect. So the right answer for this question here is Seebeck effect. Chalo, let us go for the next question. Try to answer this question. Make it fast. See here, how to answer this question. A metallic strain gauge of resistance Rx with a gauge factor is 2. So the gauge factor is given as 2. Is bounded to a structure made of a metal with a modulus of elasticity. The Young's modulus is given as 200 giganewton per meter square. The value of Rx is 1 kilo ohm. So the resistance is given as how much? 1 kilo ohm. When no stress is applied, Rx is a part of a quarter bridge with 3 other identical resistors 1 kilo ohm each. Okay, so we can use the formula as quarter bridge expression, we can use it. Yes, quarter bridge expression we can use it. DC voltage of 4 volts. The DC voltage is given as how much? 4 volts. Next, subject to the stress, the stress is given as 100 mega Newton per meter square. Okay, magnitude of the output is asking, so V naught. So quarter bridge का output क्या है? Vs by 4 into del R by R. So this is Vs by 4. So this is a gauge factor into strain input. But strain input is not given. Why? Because we know the gauge factor formula. Gauge factor is equal to del R by R divided by del L by L. So gauge factor into del L by L is equal to del R by R. So from this, del L by L is equal to 1 by gauge factor into del R by R. Okay, so this is Vs by 4 into gauge factor into strain input, that is 1 by okay. So here fine, but from the Hooke's law we can know that Hooke's law. So what is the Hooke's law? Young's modulus is equal to stress by strain. So from this we can write strain is equal to 1 by Young's modulus into stress. Okay, so here 1 by Young's modulus into stress का answer लगाओ. So please substitute now all the answers you are going to get. What is asking? Is asking the output voltage. So Vs is equal to 4 volts. Gauge factor is equal to 2. Young's modulus is given as how much? 200 giga. That is 200 into 10 power 9. And the stress is given as 100 mega. So that is 100 into 10 power 6. So if you simplify, how much you are going to get? So this is 200, this is 2, 2 gets cancelled, 4 gets cancelled. So 1 millivolt is the answer, right? So the right answer for this question here is 1 millivolt. Any doubt? Yes, Chandani, 1 millivolt is the right answer. Okay, so answer is 1 millivolt. Let us go for the next question. Answer this question. So this question, linear variable differential transformer, that will go for linear position, thermistor will go for temperature, strain gauge will go for torque, diaphragm is related to pressure. So 1 goes to R, 2 goes to S, 3 goes to P, 4 goes to Q. So option C is the right answer. Now, can you answer this question now? Make it fast. What can be the answer for this question? Temperature sensor input is given as 50 to 150 degrees Celsius and current transfer is given as 4 milliamperes to 20 milliamperes. So if you see the entire transducer setup, so if you see the entire input and output setup, so this is the input, so that is 20 minus 4 milliamperes divided by 150 minus 50 degrees Celsius. So 16 divided by 150 minus 50, that is 100. So this is milliamperes per degree Celsius. So answer is 0.16 milliampere per degree Celsius. So the right answer for this question here is what? 0.16. Chalo. Let us go for the next question. Yeah, you try to answer this question. A linear potentiometer, which is in the form of 0 to 10 kilo ohms, is used to measure the water level as shown in the figure. The resistance between the A and C varies linearly from 0 to 10 kilo ohms for a change in water level from 0 to 20 centimeters. The sensor is excited using a DC voltage of 10 volts. So this DC voltage is of 10 volts. Okay. with an internal resistance Rs. This Rs is given as 200 ohms. Okay, if V out, where is a V out? So V out corresponds to here. So this is the V out. V out corresponds to how much? 5 volts. The water level is dash centimeters. So please try to answer this question. It's a very tricky question. Question is on potentiometer. I'm giving some time for you. So try to answer this question. Anybody can answer this question? A linear potentiometer is 0 to 10 kilo ohms, water level 0 to 20 centimeters. "20 centimeters corresponds to 10 kilo ohms. DC voltage E0 is proportional to EI. See, always how to remember this. This output voltage, whatever the output voltage that you are getting, so E0 is proportional to EI. Am I right? In potentiometer, what is the basic concept? In potentiometer, E0 is proportional to EI. So if I remove the proportionality, I am going to get K into EI. So this K I can written as Xi by Xt into EI. So E0 by Xi is nothing but the sensitivity of the potentiometer. So that I can take it as EI by Xt. So sensitivity we can calculate. EI is given as 10 volts and Xt is the length of the potentiometer. I think length of the potentiometer is 0 to 20 centimeters. Why? Because he has mentioned clearly linearly from 0 to 10 kilo ohms for change in water level from 0 to 20 centimeters. That means what? When water level is 0 centimeters, the resistance is 0 kilo ohms, and when 20 centimeters is the highest, that means it is 10 kilo ohms. So when it is at B it covers 20 centimeters, at A it covers 0 centimeters. At A it is 0 kilo ohms, at B it is 10 kilo ohms. So now this is 20 centimeters. Okay, so I'm going to get 0.5 volt per centimeter. So from this I can write the output expression. So what I can write? Sensitivity is equal to E0 by Xi. So from this I can write E0 is equal to sensitivity into Xi. Now already we got the sensitivity. Sensitivity is equal to 0.5 volt per centimeter. Am I right? So this is 0.5 volt per centimeter. And the input displacement we don't know. What is the displacement if a V out is equal to 5 volts is asking? So these are 5 volts and input displacement is Xi. How much? So volts gets cancelled. So Xi is equal to 0.1 centimeter will come. So that is the right answer. If anybody is having any doubts, let me know. One second. I think this question कुछ tricky है. एक second. Why? Because we have a 200 ohms also here. We have a 200 ohms also here now, so we should be very careful. Wait. So let us wait. So see here, it forms like a different circuit. Just wait. This analysis can be wrong. The reason is the circuit is voltage, it is forming like a voltage divider circuit. Just wait. The circuit is forming like a voltage divider circuit. Why? Because there is a series resistance. There is a series resistance here. There is a series resistance. We should be very careful. Wait. So now let us take the total circuit like this. So this is my supply voltage. This is a supply voltage. The supply voltage is how much? 10 volts. And this is the resistance. This is equal to 200 ohms. Okay. And for that we are having a series resistance like this. So this is the A, this is the B. And the V out is coming here, right? At the point C. So V out is coming at the point C now. So let us take this as R2, this is R1. So V out we have to find. Okay. So I think it's a voltage divider circuit का concept आ रहा है ना इसका. Any corrections here? Actually, see here is corresponding that so the total resistance A to B will be 10 kilo ohms. I think we have done correct only. So the A to B resistance, the resistance of A to B is how much? 10 kilo ohms. The resistance of A to B is 10 kilo ohms. The XT is also how much? Is it covering? 20 centimeters water level. 20 centimeters. So 20 centimeters are covering to 10 kilo ohms means 1 centimeter covers to how much? 10 by 20 kilo ohms. That means 1 centimeter covers to 0.5 kilo ohms. 1 centimeter covers to 0.5 kilo ohms. Am I right or not? Okay, done. So if you take the V out now in the picture, V out will be what? This R2 by R2 plus R1 plus this R into supply voltage. The question here is, we have to declare the R2, V out is giving us 5 volts. And it is very clearly mentioned that the output is 5 kilovolts. But this 200 ohms is a very negligible resistance na, compared to 10 kilo ohms. So we can take approximately. Any other answers we are getting? RS series resistance is there. So V out DC voltage, Vs is equal to 10 volts. 0 to 20 centimeters is given, everything is fine. 10 to 20 centimeters corresponds to 10 kilo ohms, 1 centimeter corresponds to that. So this is the output voltage cannot exceed 10 volts, right? So the maximum output voltage comes at 20 centimeters. So we can understand like this, at 20 centimeter it corresponds to 10 volts. Why? Because it cannot exceed this voltage. So 1 centimeter corresponds to 0.5 volts. Yes. So at 0 centimeters the V0 is equal to 0 volts. At 20 centimeters the V0 will be equal to 10 volts. Why? Because both will be parallel na. If it comes here, this and this both will be parallel, so this is 10 volts. Am I right or not? Okay, 1 second. At 20 centimeters 10 kilo ohms means, okay, suppose at 20 centimeters, see here, at 20 centimeters this total resistance RAB is equal to 20 kilo ohms. RAB is equal to 10 kilo ohms. So now at 20 centimeters we have to find out V out is equal to this total resistance RAB divided by RAB plus this resistance R in series na, both are in series, into supply voltage. The supply voltage is 10 volts. So how much I am going to get V out at that moment? Suppose if you are taking this as 10 kilo ohms and this is 10 kilo ohms and this is 200 ohms, okay na, into V is equal to supply, that is equal to 10 volts. So of course approximately it is some equal to 10 volts only will come, I think so, but in the denominator we are having 10,000 plus 200, 10,000 divided by answer 0.98 into 10, so slight variation is coming, 9.8 volts. Okay, 9.8 volts is coming. V out. Now it is coming as something, so it will be some center, we don't know that. Okay, so the question here is, now the V out is coming as how much? The V out is coming as 5 volts. So the V out is coming as 5 volts. This R2 we don't know, so R2 plus R1 we don't know, plus R we know 200, and this is 10 volts. So if you simplify, you are going to get the ratio of that. RAB we know 9.8 volts corresponds to RAB, yes or not? So V out, somewhat complication going on. So V out 9.8 volts corresponds to how much? 20 centimeters. 9.8 volts corresponds to 20 centimeters. So if we take 1 volt corresponds to 20 centimeters divided by 9.8, in that case also it is not coming. So yes, for 5 volts it corresponds to 20 centimeter by 9.8 into 5, so that will be 10.2 centimeters. Very good question actually. So the right answer is 10.2 centimeters. Okay, so, right question, right answer. Very good question actually. Why? Because there is a series resistance, you have to understand. The series resistance matters here. Okay, at 20 centimeters we are going to get 10 volts is a wrong option. Why? Because at 10 volts is it's not parallel. Why? Because there is a series resistance. So when it is at 10 centimeters, when it is at AB, RAB is 10 kilo ohms. Suppose if we are taking this RAB as 10 kilo ohms, okay, so XT is equal to 20 centimeters. This total length is 20 centimeters. This total length is 20 centimeters. Water level is maximum. So 20 centimeters corresponds to 10 kilo ohms, means 1 centimeter corresponds to 0.5 kilo ohms. And we are getting that at 0 centimeters, 0 ohms, 20 centimeters, 10 kilo ohms. Why? Because this total resistance is, total distance is 20 centimeters, corresponds to maximum resistance of the potentiometer 10 kilo ohms. At that moment, what is the V out at a maximum situation? At full scale, I have noted for the full scale. At full scale displacement you can find out. At full scale water level. At full scale level, what happens? It will be here now. When it is here, this total resistance is how much? 10 kilo ohms. At 20 cm, 10 kilo ohms. So we know that V out is equal to RAB by RAB plus R. Why? Because there is a series resistance is coming here. So RAB is 10 kilo ohms. R is equal to 100. So from that we got 9.8 volts. So 9.8 volts is coming for a distance of 20 centimeters. So from this you can do scaling. For 1 volt it much, for 5 volts this much. So answer is 10.2 centimeters. So 10.2 centimeters of water level corresponds to that. It's a very, very good question. At 10.2 centimeters it is coming as 5 volts. At 20 centimeters it is coming as 9.8 volts. At 0 centimeters it is coming as 0 volts. So this is the table. This is all because of the series resistance. अगर हमारा पास series resistance नहीं है तो 20 centimeters के पास 10 volts आएगा. Why? Because that series resistance will have certain drop. Do you understand this question? He has used the concept of voltage division rule of the network theory. What a बढ़िया concept है. चलो, let us go for the right answer is 10.2 centimeters. चलो, let us go for the next question. I hope you are up for following. So let us see this question now. Answer this question, make it fast. Yeah, answer this question. Can anybody answer this question? Anyone in the live? So see here, the capacitor shown in the figure has parallel plates with each plate having an area A. Each plate having an area A. The thickness of the dielectric metals are D1 and D2 and the relative permittivities are epsilon 1 and epsilon 2 respectively. Assume that the fringing field effects are negligible and the epsilon naught is a permittive free space. So this epsilon 1, if D1 is decreased by epsilon D1, the resultant capacitance becomes as dash. Yeah. So D1 is decreased by delta D1. So this D1 is decreased by delta D1. So first of all, these two plates are in series. So for a series situation, for a series combination, we know that 1 by C is equal to 1 by C1 plus 1 by C2. So this is 1 by C means epsilon naught epsilon R1 A1 by D1 plus this is 1 by epsilon naught epsilon R2 A2 by D2. So now from this, what we can do here, okay, okay. So in the beginning case, this is epsilon naught R1 is given as epsilon naught. This is epsilon R1 is given the picture as what? Epsilon 1 and this epsilon 2. So this is epsilon 1, overlapping area is same, and this is T1 plus this is epsilon naught, this is epsilon 2, this is A by T2. Okay. What happened here? What is epsilon 1? Air is the medium now. So initial situation la air is a medium. So what happens? So if you take this air as a medium, epsilon 1 is equal to air na. So air is a medium, so that you can take as epsilon 1 is equal to 1. So I can write 1 by C is equal to 1 by epsilon naught into 1 A by D1 plus 1 by epsilon naught. Epsilon 2 is this. So this is epsilon 2 and this is A divided by D2. Okay. So now if I am taking this 1 by C, what I am going to get? 1 by epsilon naught A, if I take common, okay, 1 second I can do here. So this is in the model of 1 by A, B by C is equal to 1 by A into C by B. So it becomes as 1 by epsilon naught of A D1 plus 1 by epsilon naught epsilon 2 A D2. Am I right? Right. Chalo. So now if I am going for this parallel combination, so this is 1 by C. If I am taking this 1 by C, so 1 by epsilon naught of A, if I take common, that becomes as 1 by D1 plus, that is 1 by epsilon 2 D2. But C, if you take, this is the epsilon naught of A, the whole divided by 1 by D1 plus 1 by epsilon 2 D2. So this is the initial at no displacement. Any doubt here? Sorry. I done a mistake here. This is a mistake, right? Any mistake we have done? I think these steps are wrong. So this is 1 by C is equal to d1 by epsilon naught of A 1 plus d2 by epsilon naught of A epsilon 2. So that will be d1 by 1 plus d2 by epsilon 2. So if you take C out, that is, if you want C, then it will become as epsilon naught of A into 1 by this one, 1 by d1 plus d2 by epsilon 2. So epsilon naught of A divided by d1 by epsilon 1, that is equal to 1 plus d2 by epsilon 2. This is at no displacement. So now there is a displacement of push downward. So the nu will be d1 minus x. Am I right or not? If d1 is decreased by delta d1, so the d1 will be what? This will become as d1 minus delta d1. When it is decreased by delta d1, so this is the delta d1. Okay, so delta d1 is applied, so d1 minus delta d1 will be happening. So this is a new gap. So now the new gap, what happens now? The C will be epsilon naught of A divided by, so this d1 I can take it as d1 minus delta d1 as it is, plus d2 will be as it is epsilon 2. So the right answer will be epsilon naught of A by d1 minus delta d1 plus d2 by epsilon. Very good question. Option A is the right answer. Option A is the right answer. Chalo, quality question say. Let us go for the next question. Try to answer this question. If you see this answer, in the 4 transducers shown in figure A, 4 identical strain gauges S1, S2, S3 and S4 are mounted on a cantilever beam such a way from its base. S1, S2 are mounted on the top of the surface, S3 and S4 are mounted on the bottom of the surface. Okay, to be connected to form a Wheatstone bridge consisting of 4 arms A, B, C, D, as in the figure B. From the following option, the correct order to maximize the maximum sensitivity. See here, the strain gauge 1 and 2 are kept on the first, on the top. Strain gauge 3 and 4 kept at the bottom. So when you apply the force, it will be bending like this. So when it is bending like this, so this S1, S2 will be experiencing expansion, whereas the bottom S3, S4 will be expressing the compression. So what I can write here, upon force application, so at force input, what happens now? This S1, S2 will be experiencing the elongation. So the strain gauges S1, S2 will be experiencing the elongation. Elongation means L plus delta L. So that means the resistance will be increasing R plus delta R. Next, S3, S4 are compressive type. So this S3 and S4 are compressive type. Compressive means L minus delta L. The resistance will become as R minus delta R. Now, these particular strain gauges are connected such a way. How we have to connect? So we have to connect, always remember like this. So this is our push-pull configuration. So this is A. So this is the situation of the Wheatstone bridge. So now I am taking this as A, B, C, D. So this is A, this is B, this is C, this is D. Okay, A, B, C, D. So now this A will become as what? Elongation now. So upper one will be experiencing. So if I am taking this as R plus delta R, I cannot take R minus delta R here. If I am taking R minus delta R, suppose if I am taking R plus delta R here, and if I am taking R minus delta R, bridge becomes balance. So this is a wrong concept. Why? Because product of opposite terms, which are A plus B, A minus B here, A minus B, A plus B, it's a wrong arrangement. So that's why I will go such a way. I will choose the Wheatstone bridge such a way. We go to such a way. So this will be so what happens now? This will be R plus delta R you take, and this also you take R plus delta R, and you take this as R minus delta R, and you take this as R minus delta R. Okay, so what happens now? So I will take A, B, C, D now. So S1, so S1, S2 means, so they should be both A and B. So this should be S1, this should be S2. Okay, this should be S3, this should be S4. So now A and C must be like this. So it should be A, it should be C. Next, BD must be like this. So this is B, this is D. Okay, A, B, C, D. So A goes to S1, A goes to S1, D also should go to S1. Sorry, C should go to S1. Sorry, C. S2 should go for C. Okay, next S3 goes to B, S4 goes to D. Why? Because this is a sequence of A, B, C, D, na? So that is the concept. S1, S2. A goes to S1. Yes. A goes to S1. Next D goes to S2. D goes to S2. B goes to S3. D goes to S4. Sorry. D goes to S4. C goes to S2. S1, S2, S3, S4. A goes to S1. C goes to S2. B goes to S4. D goes to S3. That is also correct. B goes to S4. D goes to S3. This is also correct. The thing is the product should be opposite. S1, S2 must be in opposite. S1, S2 must be in opposite. S3, S4 must be in opposite. So option D is right answer. So option D is right answer. जितने लोग लाइव में हैं मुझे कंफर्मेशन कर दीजिए बेटा, जिंदा हो, जीवन में हो. How many of you are watching the session? चलो now try to answer this question. Last question of the day. I'm not interested. ऐसा YouTube session में बच्चे नहीं देखते sensor session को. That's a problem. Air-filled parallel plate electrostatic actuator is shown in the figure. So this is the figure. So this is the figure. So this is a force is applied, then the spring moment will happen. The capacitance will be changing. The charge will be changing. So what is mentioned? See, a air-filled parallel plate electrostatic actuator. So what is this? Air-filled parallel plate air-filled parallel plate electrostatic capacitor. Electrostatic capacitor. Air-filled parallel plate electrostatic capacitor I have discussed here. So first of all, it's air is the medium. So try to understand this is air. So this is also air. Air-filled parallel plate capacitor. An air-filled parallel plate electrostatic actuator is shown in the figure. The area of each capacitor plate is 100 micrometers to 100 micrometers. So area is given. Each capacitor plate area is given. So area is equal to 100 micrometer cross 100 micrometer. That means how much it is coming? 100 into 100. So that is 10 power 2, 10 power 2, 10 power 4. So 10 power 4, 10 power minus 6, 10 power minus 6, 10 power minus 12. So 10 power minus 8 meters square, right? 2 power 4, minus 6, minus 6, minus 12 plus 4, minus 8. So 10 power 8 minus 8 meters square. That is the area of cross section of each plate. The distance between the plates D0 is 1 micrometer. So the distance between plates D0 is equal to given as how much? 1 micrometer initially when the spring is not contracted. Okay, when both the capacitor charge and spring restoring force area 0 as shown in the figure A. When both the capacitor charge and spring restoring force are 0, both the capacitor charge Q is equal to 0, restoring force is equal to 0 at this moment. Linear spring constant K is given. The spring constant K is given here. So the spring constant K is given as how much? 0.01 Newton per meter. So this is 0.01 Newton per meter. Is connected to the removable plate. When a charge is supplied to the capacitor using current source, the top plate moves as shown in the figure B. So then there is a force of attraction. So when a charge is connected here, so there's a source is connected here, it comes down because of attraction. The magnitude of minimum charge required to momentarily close the gap in the plates is dash. So what should be the Q such a way that D should be equal to 0. Okay. Assume a full range of motion is possible for the top of the plate. There is no fringe capacitance, the permitted free space, everything is given. So here there are two forces, my dear, you have to understand. One is a spring force is acting, one is a spring force, other one is an electrostatic force. Okay, so the D must be 0 means this has to come closer now. That means the spring has to expand this much. The spring has to expand this much. The spring has to move this much. So there are two forces here. One is the electrostatic force, other one is the spring force. So when it comes closer now, when the gap is completely becoming closer, what happens? Electrostatic force is equal to that one. Okay, so the electrostatic force of the capacitors must be equal to the spring force. So we all know that spring force is equal to what? F is equal to Kx. So this is the electrostatic force I am writing, Fe, and this is Fk. So electrostatic force everybody knows, right? Electrostatic force everybody knows. That is in Q square by 2 epsilon A, right? Q square by 2 epsilon A. Okay, so that is electrostatic force that is given by formula in EMT, that is Q square by 2 epsilon naught into epsilon R into A, and we know this is K into X. Epsilon is equal to 1, so Q square by 2 epsilon naught, air is the medium, so 1. And what is this gap he is asking? The total gap has to be covered, right? The total gap has to be covered. You have to understand the total gap has to be covered. So what is the total gap? That is the air gap. This is the gap. So that is the D naught total has to be covered. So that is K into D naught. K into D naught. So now what is asking? The value of Q is asking. So Q is equal to square root of K into D naught into 2 epsilon naught into E. So let us substitute all the values now. So what is the K? K is given 0.01 Newton meter. Next, what is the D naught? D naught is equal to given as 1 micrometer, that is 1 into 10 power minus 6. Next, this is 2. What is epsilon naught? Epsilon naught is equal to 8.85 into 10 power minus 12. Epsilon naught is equal to what? 8.85 into 10 power minus 12. And what is the area? Area is given as 10 to the power minus 8. So if you simplify, how much I am going to get? So Q is equal to 4 into 10 power minus 14 coulombs. So what is the answer? We're going to get 4 into 10 power minus 14 coulombs. That's it. So the right answer is 4 into 10 power minus 14 coulombs. Very good question actually. Quality question. Okay, enough for today.